Hi, my name is Aruj Bansal, and today we'll be solving the problem Couple in Ruins Land. It has a difficulty level of Cakewalk, and you only need to know basic math to solve it. Let's now take a look at the problem statement. So you should now pause the video and read the problem once on your own if you haven't already. Because this problem statement is a bit convoluted, I'm going to explain it over here. So in this problem, we basically have an array of n integers, and we're told that every integer in that array is greater than 0. What we have to do is we have to come up with an array B such that AI XOR BI is prime for all I, and B of I also has to be greater than 0, and our task is to minimize the sum of AI XOR BI. So if you don't know what XOR is, we essentially in binary, if we take a look at bits, if you don't know how numbers are represented in binary, you should first understand that and then come back to this video. And after that, if we take a look at bits in binary, if we have 1 and 1, then their exclusive OR will give us a 0, 0 and 1, their XOR is 1, 1 and 0, their XOR is 1, and 0 and 0, their XOR is 0. In order to have 1 as an output, we need to have an odd number of 1s in our input bits. So what we have to now do is we have to create this array B such that AI XOR BI is prime, and we have to minimize the sum of AI XOR BI. So we can actually minimize the sum by minimizing the individual exclusive ORs of these elements. So how do we approach this problem? What are the smallest prime numbers? We have 2, 3, 5, 7, and so on. So our goal is to make AI XOR BI equal to 2. And how do we do that? Let's say we have a number P that is known to us, and we have to find some Q such that P XOR Q is equal to 2 or any other number. So how we can do that is simply P XOR 2, and this will give us the required value of Q. So the number you want to find, you XOR that with the number you already have, and you'll find the missing number. So here, for example, if we did A2 XOR 2, then we would find the value of B2 required. So consider the example array. Let's say we have 3 and 4, and we want to find some B of I such that 3 XOR B of 1 is equal to 2. Then what we'll do is 3 XOR 2 is equal to B1. What are they in binary? 3 looks like this in binary. And what does 2 look like? 2 simply looks like this in binary. So what is their exclusive OR? We have 1, 0, 0. So 3 was 1, 1, 0. If we did its exclusive OR with what we got as our output, which is 1, 0, 0, which is basically 1 in decimal, then we would get 2, which is 0, 1, 0. And we could do the same for 4. So you should try to do the same for 4. And so the number you should be getting is, the first bit will be 0, and then the second bit will be 1, and then your third bit will be 1. So this is 2 to the power 0, 2 to the power 1, 2 to the power 4, which will give 2 to the power 2, sorry, which basically gives us 6. And if you do 6 XOR 4, what is 4? This is 4, and you end up getting 2 again. Alright, So we can see that if we simply just calculate its XOR with 2, we get a required B value. But we have one condition that any B value has to be greater than 0. So what happens when we actually have 2? What happens when AI is equal to 2? So XOR has this property that x XOR x is equal to 0. If you XOR a number with itself, it becomes 0. So we can't actually do 2 XOR 2 because that would give us 0, and the B value can't be smaller than equal to 0. So in this case, we look at the next biggest prime, which is 3. So we can simply just do 2 XOR 3, which will give us our required BI value in case in case a of I is equal to 2, because then we cannot do its XOR with 2. And so that's how you solve this problem. It's pretty simple. If a of I is equal to 2, then you can't set b of I equal to 2. You set it equal to AI XOR 3. Otherwise, you can just simply set it to AI XOR 2. Alright, let's take a look at some code for this problem now. So this is a Python code for this problem. We take an input. This is our array. Now we loop over every element in A. If that element XOR 2 is equal to 0, meaning that element is 2, then we print its XOR with 3. Otherwise, we print its XOR with 2 because we know it's not 2. So the time complexity for doing this will simply be O of n because we're making a single pass with a for loop through the array. Some C++ code. Same thing, we take in n, the array, and now this code is slightly different. We're directly checking if it's equal to 2 and we're not checking XOR 2, but it's the same thing because 2 XOR 2 will be 0, and we can just check that the same way by doing x double equals 2. So if that's the case, then we print its XOR with 3. Otherwise, we print its XOR with 2. Alright, let's also take a look at an error code. So in this code, we can see that we aren't considering the case XOR 2 and XOR 3. And it's really easy to actually miss that in this problem because it's easy to miss that your strength value has to be greater than 0. So make sure you keep that in mind and you do include these two cases. Alright, that will be it for this video. I hope you enjoyed solving this problem on XOR. We upload videos like these weekly, so make sure you subscribe to the channel and press the bell icon to stay notified about them. I'll see you in the next one.